Hello, everyone. Thank you so much for joining this session today. This session is all about working with your data in your products. I'm Kelly Holleran, and I'm joined here virtually with my colleague Max Payson, and we're both solutions engineers on the Partner Technical Enablement team. As with all sessions, we really appreciate your feedback, so be sure to click on the survey link directly below this video. And the purpose of this session will be to provide you with some tips and tricks for working with your user data across multiple tenants. And this can really mean a couple of things. It could mean that your users could have their own data hosted in their own GIS deployment, and you want your application to be a client to that. It could also mean creating new data services on behalf of your users so that those users can access and interact with those data services that you created through your application so they can use it for the workflows that you are building. And the high-level agenda for today is that we'll start by going through an overview of the different layer types that exist in ArcGIS. We'll briefly touch on Arcgis Platform as you can now host your data in it. And so we'll talk through how that works. But the majority of the session will be spent talking through ArcGIS Online and ArcGIS Enterprise, where there are more tips and tricks about working with multiple users and multiple data sets to help give you ideas on how to work with that user-specific data. So we'll talk through creating services, provisioning services, and then accessing those services, all using code, of course. So let's start by going through an overview of data in ArcGIS. And just as a reminder, ArcGIS supports all different types of data. There's imagery, multidimensional, tabular, unstructured, vector-based content, even 3D content and layers. There's been a lot of advancements for ingesting real-time data or the Internet of Things, really big data sets to be able to process and extract those to be able to do analysis at scale. There's also support for LiDAR along with the advanced tool sets we have there. And finally, CAD and BIM. And all of these data types are being brought in as web services to visualize in maps or 3D scenes. And this table is a really good visual to help you understand some of the common layer types we have in ArcGIS, as well as the REST API service you can access for that layer type. So throughout this presentation, you'll probably notice we interchange feature layer and feature service. This table really shows that feature layer is more on the conceptual side, whereas the feature service is that REST API that backs it up. But since this is a WebGIS world, we're often talking about the feature layers being delivered as web services anyways. So they really can be used interchangeably. And then here you can also see the different hosting options that are available for each layer type. So whether that is through ArcGIS Online or ArcGIS Enterprise, and whether or not the layer type is able to be cached. And all of these layer types are really intended to work with different kinds of data. But as you can imagine, in order to work with the same types of data, there can be some trade-offs in terms of performance. So for example, load time versus interactivity, or pre-computed and cached layers, such as the tile layer, versus layers that are, more dynamically computed and sometimes cached, such as the feature layer. So as you start thinking and planning for the different types of data that you want to use and how you want to represent them in your application, it's, really important that you understand these differences. So let's walk through a quick overview of each of these layer types, starting with the feature layer. And this is the most common layer type we have and will be the focus of this presentation. So feature layers really enable you to query, render, and edit vector geographic information, and they are represented by JSON objects. So here you can think of features as points, lines, or polygons, and are used to visualize data on top of base maps. They are all backed by a database that supports transactional edits and analytical queries. But the queries can also be dynamically optimized and compressed as well as efficiently cached for a very fast data display. So as a developer, being able to work directly with the source data allows the feature layer to re-render or query on the client side. And feature layers are a very advanced layer type and have so many visualization capabilities for you to take advantage of. Next, we have the tile layer, which is great for complex rendering requirements. These layers help you display base maps and other complex data sets that are changing infrequently. And they are stored as image files and can be pre-rendered for a fast display of relatively static data. So, for example, if you think of a base map with tiles of streets, these streets are not changing very often and are primarily used for visual reference. Therefore, a user would not be editing or working with the source of that data. But as an option, you can also enable your tile layers to stay in sync with your feature layers so that the tiles are updated when your feature layer is updated. And then there's the vector tile layer, which again can display base maps and other complex data sets that are changing infrequently. But here, instead of being represented as images, they are being represented as vectors. So again, you can think of those points, lines, and polygons. And by storing a vector representation of the data, allows the vector tile layer to be able to adapt to the resolution of their display device and be restyled for multiple users. So for example, hiding the layer's visibility or changing the symbols and fonts without actually having to regenerate the tiles each time. And they also have a smaller file size than the raster tiles, which allows for faster maps and better performance. But again, similar to the raster tiles, the user would not actually be editing or working with the source of the data as they're a pre-computed cache. We also have the dynamic map layer, which helps you display very complex data sets that change frequently or need complex rendering requirements. So these layer types are rendered on the server and sent to the client as an image. And this allows your users to interact with your maps and be able to dynamically change the layer's appearance and behavior in your map service. Dynamic map layers are best for very, very complex data or massive volumes of data that need to be computed on the server without actually streaming that raw data to the client. We have the image layer, which allows you to render, analyze, and dynamically interact with imagery data. And these are again represented as images. The image layers dynamically composite massive volumes of standalone imagery files into a single image that then gets sent to the client. So it can also dynamically interact or perform analysis, such as transformations of pixel calculations while doing so. And this means that you can visualize the data relatively quickly without needing to store pre-computed representations of that imagery for each transformation. So as you can imagine, if you had, very large volumes of data, such as a terabyte or even a petabyte of data, you don't want to have to store 1 petabyte of data for RGB and 1 petabyte of data for NDVI and so on. So the image layer really allows you to do this without needing to store that pre-computed representation for each transformation. We have the scene layers, which enable you to display and render 3D data sets, which are being optimized for displaying large amounts of 3D data in a scene. The scene layers display one of 5 data types. So there's points, point cloud, 3D objects, building, or an integrated mesh, all of which are then represented by the indexed 3D scene layer or I3S specification. And scene layers are cached when you share to the web to help improve the drawing performance. But as an option, when you have a hosted feature layer that's associated with the scene layer, you can edit the feature data and keep the scene layer in sync with those changes. But many times, and most often, you have a combination of all of these layer types, and you want to be able to bring them all together to create a map or a scene to leverage within your application. And for 2D data, we do this through web maps, and for 3D data, we do this through web scenes. And both of these are being represented by JSON objects that are either defined by the web map or the web scene specification. and it contains the configuration settings for the map extent, layers, styles, pop-ups, camera height, angle, etc. And this is really nice because a lot of you might remember managing a lot of these configurations within your application, and now they're all being stored within your web map or your web scene. So this really enables you to take this configuration across all Esri or developer applications, and the maps are going to look the same across the board. So this really allows your organization to have these authoritative web maps of how they should be brought together and represented. And we also have a variety of capabilities and tools for you to take advantage of when it comes to authoring. We, of course, have our core client product, ArcGIS Pro, where you can go in, load the data, and author those web maps and layers and web scenes to either ArcGIS Online or ArcGIS Enterprise. But we also have tools natively within ArcGIS Online and ArcGIS Enterprise. Or today we'll go through some scripts and examples of how you can use the ArcGIS API for Python to author and publish content using Python notebooks or really anywhere that Python is supported. But before we dive into all of that, I'm going to hand things over to Max to talk about our newest release of ArcGIS Platform.
All right. Thanks, Kelly. Hey, everyone. So let's start by talking about working with data in Arcgis Platform. So Arcgis Platform is Esri's new platform as a service offering. It contains standalone services that you can composite into your own applications and systems to add geospatial functionality. And one of those standalone services is this ability to host your own data. So a couple notes about this is that one, you can upload different file types into ArcGIS Platform and then emit those files as these different services, like feature services, raster tiles, and vector tiles, to Kelly's discussion earlier. And generally, the pattern for ArcGIS Platform is that the data that you host is provided to your application. And so it's used by all of your users of that application. And then you can secure that data by creating an API key and scoping that API key to your app and the services. So you can now add geocoding to your application, you can add map tiles to your application, and you can also add your own value-added data to your application as well. So as you can tell by that sort of bare or minimal is the right word, diagram on the right, this is a pretty straightforward concept. So I think the best way to talk more about it is just to show a quick demo. Okay, so let's switch over from the slides to the browser. And so here I am logged into ArcGIS Platform with my mp_pass_demo account, and I would like to add a data set that I can use in my app. If I go over to the Layers tab, I'm able to import data, which for now I'll import a snow emergency parking lots GeoJSON file. We recently got a lot of snow where I am, and so this has been a helpful data set. What I'm next going to do is just add a tag and a quick description, and this is going to upload that file into ArcGIS Platform, essentially pipe it into a database, and then emit these feature services or optionally other types of services against that data. And one of the supported clients to ArcGIS Platform is the Arcgis JavaScript Api. So what I'd like to do is I'd like to use this data in an app. In my second tab here, I have the ArcGIS API for JavaScript sample for adding a feature layer. And if we open this up in the sandbox, we can see that the way that the data is loaded is just by referencing the URL. So if I go back to this tab and I grab the URL for my data layer, and then I copy this in, we can now hit refresh, and we'll see that we'll get a authentication challenge here. And that's because this data is secured, and we need a way to access that secure data. And that's where the API keys come in. So going back to the developer dashboard, we can scroll down and actually create a new API key, which we'll call demo. And on the API key page, we can now assign that item to the API key. So when we use this API key in the app, we'll be able to access the item. I'll copy the string, and then going back to the source code, the way that you specify the API key in the JavaScript API is by defining it against the config object. So we'll load that config here, and then we'll say that the config.api key equals that string. And when we refresh, we'll see there's no longer authentication challenge, and this is snow emergency parking lots in Boston, so we actually need to go over to the right spot. And when we do that, we'll see that that data is now showing up. So this is something that you can do in your own apps. You can create these layers and then secure them by an API key so that when users go into your application, they are able to access that data layer in your app. And there's some best practices around working with API keys that you can find on the developer website. Okay, so going back to the slides and diving back in, that was sort of an overview of working with data in Arcgis Platform. Next, let's talk about working with data in Arcgis Online and Enterprise. Now here, the pattern that we're going to talk mostly about is no longer data sets that are used by all of your users within the app, but actually creating data sets for individual users or groups of users, and then using the sort of framework that comes with Arcgis Online and Enterprise to administer, maintain, share, and control those layers for your apps. And the first part of that is just creating the layers or data services in the first place. In this case, we kind of see a few main challenges working with developers and partners. The first is working with many data sets. So you might be creating within Arcgis Online or Arcgis Enterprise for your applications one data set per user, maybe one data set for groups of users. But in any of those cases, that becomes increasingly more data sets to manage. And ideally, you want these data sets and items to have a consistent experience, and you want to be able to automate the management of this without manual intervention. So generally what we recommend here is to author, quote, template services in the UI. And the reason why template is in quotes is because they're just any other ArcGIS item. But in creating that item through the UI, you define properties that get serialized, and then you can use those properties to create new services for different users or different deployments, and copy the properties into that so that they have the same behavior. And this can be automated, right? Another sort of corollary is if you're familiar with ArcGIS Pro or the desktop tools, then you can also create service definitions, and those act as the template. But for the purposes of this, we're just going to work in Arcgis Online and show a similar concept. So that's really what this next demo is about, is we're going to show just creating an item. It'll be a very familiar workflow if you've seen ArcGIS demos before, and then we'll dive into how to use this item that we created as a template for new items in a deployment pattern. Okay, so switching back to the browser, we'll minimize this past environment, and now we're in Arcgis Online. So I'm signed in with an Arcgis Online account, an administrator account, Spatial Startups, and I'd like to add a item. So this is the ArcGIS UI to import a file and host that as a service. So we'll use the same snow emergency parking lots GeoJSON file, and we'll add a tag dev 2021 and upload it. Again, this is going to take that file, pipe it into a database, and emit a feature service on top of it. Here we can see the item landing page for this service, and you can add metadata about the item. So we can say that this is my fun summary, which is super descriptive, almost as descriptive as this is my fun description. And we'll save this. And there are other things you can add here as well. So you can also add terms of use. You can update the tags from the creation process as well. And just to take a quick second, part of the reason why this page is important is because if you're working with data in ArcGIS, sometimes that data may just be used by your application, and your application is the only interface to that data. But in other cases, your application may be generating these data sets, and those data sets are going to be used by your users in other applications or in other environments, such as in an ArcGIS field app. And having this metadata can provide additional context for when your users discover or use the data in other applications that you yourself did not build. Okay, so going over to the data tab, we can see that this data was in fact uploaded and is hosted as a service. And of course, we can visualize the data on a map. And what I'd like to do is I would like to adjust some of the default properties for this data. So rather than use these default orange dots, let's instead use a parking lot symbol. And there's a parking lot symbol within the government symbol set. So scrolling down a bit, we can see that here. Hit OK. And now we have this sort of nicer parking lot representation of the parking lot data. We can also control the pop-ups. So if we look at one of these right now, we see that there's a lot of pop-up information, and maybe as part of the default experience, we don't want to show all that. So we can also adjust the pop-ups. Let's say we just show the name in the title, and then we want to configure the attributes to just show, how about the address, the spaces, the fee, and the phone number. Hitting OK, OK. We see that now the pop-up is limited and only shows that information that we defined. So I'll hit save, and this will serialize these properties into the service. Going back to the slides. Okay, so now back in the slides, a little bit of a look behind the scenes at what's happening here is that these properties are getting defined at multiple tiers. So there's the item properties tier that contains that metadata, so the description, the tags, and other information. And that tier is represented at that /item_id endpoint. So that's the REST API that you use to get these properties. And if you see any URLs in future slides, those are all the corresponding REST API endpoints. The next tier is the item data tier, and this contains some more information about how to represent the data itself, like pop-ups, clusters, or clustering and filters. And then finally, there's the service level properties, and this contains additional information like the rendering, the visible range, as well as editing controls. Now, most of the time, you don't interact with these properties yourself. You generally use ArcGIS APIs or clients to work with them, but I think it's kind of helpful to have an understanding of how the system works behind the scenes. To talk about editing properties specifically, I think this is a powerful notion, and to Kelly's point earlier, one of the interesting things about these feature services in this particular example is that you can transact against the underlying database and then still visualize and analyze the data efficiently within your client applications. And so you can control what kind of editing or transactions can happen against that source data. And you can specify permissions and tracking as well, so that if a user comes in and edits a record within the database or within the data service, then you can record that as a field within the table or within the layer, for example. And then the actual people that are able to perform these actions that you defined as permissible on the layer is controlled via sharing. And that's something that Kelly will talk about in her next provisioning section. Another good note about feature layers specifically and setting properties on them is that there's this notion of feature layer views. So you can create a source feature layer and then create essentially database views on top of that, which still reference the underlying data, but can have different sets of properties. They can be used to only show subsets of the data and otherwise have different behaviors and permissions. So that means that there's this provides a sort of compelling data management technique where you can just have one authoritative layer, but then represent that or control that in different ways for different personas of your application. Finally, one sort of side note is a lot of this presentation is talking about feature layers, and those are some of the examples here, right? Because that's generally the most common data type that we see implemented. But some of these concepts are universal across ArcGIS. So that item properties JSON object that I showed earlier, that's the same across maps and apps as well. And specifically for web maps and web scenes and some of the applications, that item data endpoint actually contains the entire configuration, which is kind of interesting. So as Kelly mentioned, a web map is this declarative JSON specification, and that's saved in the data endpoint. Okay, I think that's enough sort of context for now. So let's switch back to another demo on how to start creating services from that template that we defined earlier. Switching back to the browser, we're going to do this in the Python API. So here I'm running the Python API in a Jupyter notebook, but the API is supported wherever I think Python 3.6 and above is supported. So I'm just going to quickly log in to my mSpatial Startups account, and let's investigate some of the properties of that item we created. So I'm going to go back here and grab the item ID and copy that in. Okay, now if we look at the item level properties, we can see some of that metadata that we defined. So we have the title, we also have that very descriptive description, as well as some other information. At the item data properties tier, we can see the pop-up information that we defined. So we said that spaces, for example, should be visible. And then finally, at the layer property tier, we can see some other information, like some of the capabilities that can be done against this layer or data service, as well as the rendering information. So the encoded image, that parking lot symbol, for example, here. So this is a lot of data, or a lot of properties. Let's hide it for now. And now let's talk about creating a service. So here's an example of how to use that existing item and create a clone of it with the same properties. This is using the Python API aptly named clone items function. And here I'm actually explicitly saying to not copy the data. And the reason for that is that I want to create a service that has some of these default behaviors, but I expect my users in the app to later go add data. And that seems like a relatively common workflow, right? So this is one pattern to create sort of that scaffolding of a service that users can then interact with in your applications. Another pattern is to create a new service, but write some default data to it. So here we have the same clone items function that's not copying any data, but we're also adding some default data into it by reading in a very similar snow emergency parking lots GeoJSON file. So let's take a quick look at the results. In the empty parking lot service, we can see that the metadata carries across, right, that we defined earlier, and there's no data in the service because this one's the empty one. In the pre-populated one, there is data. So we see 49 records, and that data is visualized on the map with that parking lot symbol and even the default pop-up. So this is kind of cool. We were able to define something in UI and then create these services that can be used in an app based on the properties set in the UI. The last part I want to show is just creating a feature layer view. So there's a good amount of code here. It's probably not strictly necessary, but what's happening is we are creating a view from the original item and then saying that we only want this view to be able to see records or features where the number of spaces is greater than 50. Otherwise, we're grabbing some item properties and keeping those the same in the view item. If we look at this, we see that all the properties, again, carried over, But on the data side, there are now only 9 visible features, and those are the 9 that have greater than 50 spaces. And this is, again, sort of referencing that same source data, but it's a different representation of that data with a different set of permissions. Okay, so going back to the slides, what's happening here behind the scenes is in the Python API, it's grabbing that item information, those JSON properties that I shared earlier, and then there are 2 ways to create new services. I believe the Python API uses the first one. So it creates a new service and then adds to the definition of that service using some of that item information. These are the same endpoints that you would use if you're using a service definition file, for example, I believe. Now, on the other option is to just publish a data file directly. So in this case, you upload a item, let's say a GeoJSON file, and then you can call publish, and that will take that file and push it into the database. So this is what happened through the UI when I uploaded that GeoJSON file. The last part is that now that these services are created, you can use some of those additional properties from the JSON objects and copy those in to make sure that everything is consistent. So this is a little bit of a look behind the scenes at some of the API calls that are being used. In general, we would strongly encourage you to use ArcGIS clients or APIs around that. The Python API, as you just saw, is one example. Another example is this library solution.js, and that is a JavaScript library. It's open sourced on GitHub that allows you to, in one line of code, create these templates, and then another line of code deploy those templates as new services. So it really abstracts this process and makes it quite easy. And the reason to use these libraries is just that the properties are a little bit opaque, and using the ArcGIS services makes it easier to avoid accidentally setting a property that ArcGIS doesn't know how to respect. The last slide in the section is just some update tips. So inevitably, something's going to need to update, and there are a couple different tips here. If you want to update the data, there are 3 API endpoints. One is, or just API methods. There's apply edits, which is for transactional and row by row edits. There's overwrite, which takes a full incoming data file and completely overwrites an existing service. And then there's append, which takes an incoming data file and adds new records to an existing data service, or optionally updates existing records based on a uniquely indexed field. And generally, at least in my work with partners, apply edits is used for transactional edits like that happen in a web application, and append is used for batch processes or ETL. To update the schema, you can use the update definition endpoint, and this can be used to add fields, set domain names, and other types of operations. And if you want to update the item properties, one idea here is to update them back in that template item through the UI. That way you know that the properties are set correctly, and then you can copy the resulting properties into the derivative services. So there are a couple examples of these sorts of operations that we have on GitHub at that URL at the top. So that was a quick tour of creating services, and I'm now going to hand it over to Kelly, who's going to talk about, now that these data services are created, how do you give users access to those services following the online security and sharing models?
All right, thanks, Max. And just a reminder about ArcGIS's security model is that we have this notion of user types. And user types really allow you to control who has access to what items within ArcGIS. And each user has roles and permissions that are assigned to them. So certain users might only be able to view items, or maybe they can edit features or actually edit the item. So we have this concept of groups, which is a way to be able to manage what users have access to. And we also have this concept of sharing and a full sharing API that allows you to control who can do what. And our security model is something for you to really understand and take into consideration for the different user personas and workflows that you're planning to support when you are designing and developing your application. And when we're talking about provisioning services to your users, there's a couple challenges that typically come up in this scope. So first, of course, how do we actually give users access to their data? And this will be the main question we'll be answering in this section. But along with that, you need to really understand in each of these scenarios who actually administers the services once your users have the access, and who pays for the services, and where is that data hosted. And these are all very important concerns when you're thinking about the different ways that you want to give users access to the data sets. And of course, there's pros and cons to the different approaches. And so the three options that we'll be talking about today is first, how do you publish data directly into a user's GIS? Next, we'll cover how to register the service in a user's GIS. And then finally, we'll talk about two different patterns of how you can share services via a group and either invite other ArcGIS users into that group or manage those users yourself. And so first looking at that pattern of publishing the service directly. Here the user is actually logging into your system with their ArcGIS credentials, giving your system an access token to act on the user's behalf. So this allows you as a developer to use that previously authenticated session in your application and then use that access token to directly write your data set into your client's ArcGIS Online or ArcGIS Enterprise environment. And once your data has been ETL'd into their instance, the user here will control access and administration privileges to that data. So with that, they are then also paying for the service because they become the one that's hosting the data. And this really works for any service that's supported by the user's infrastructure. So it could be a feature service, but it could also be an image service or real-time data feed if they have the appropriate software and GIS infrastructure in place because you're writing that into their environment. Now, the next few patterns that we're going to talk about only apply to partners when used in a revenue generating product. So just keep that in mind as we go through these next three patterns. But the way it works to register a service is that you have your data in your own infrastructure. So in this diagram, this is labeled as partner infrastructure, and it could be either ArcGIS Online or ArcGIS Enterprise. And for this example here, we are showing the diagram for an image server. And that's actually an important note because we've been primarily talking about feature layers as they are the most common. But now we're talking about provisioning services, and this really can apply to any layer in ArcGIS. So when you're registering that service, you have that data in your own infrastructure, and you would create credentials for that user in your own environment and give those credentials to a user. So they would then reference that service and enter those credentials that you gave to them, and their organization would act as a proxy to that service. So the user in this scenario is controlling the access because when they request that service, it's grabbing the credentials that you gave to them and then forwards the request onto your server. But in this scenario, the developer controls the administration and pays for the services because the data is still living within your own environment. And this works for any service that you have set up in your own ArcGIS Online or ArcGIS Enterprise environment where the data is actually hosted. For sharing services, this is again partner specific, but for this pattern, instead of giving the user credentials, you're taking advantage of ArcGIS Online's built-in multi-tenancy. So here you take the data from your own infrastructure and ETL it into ArcGIS Online. From ArcGIS Online, you can then share that data into groups and invite any ArcGIS user into that group. And you can create as many groups as you would like. So as a best practice, we typically recommend creating a separate group for each client. And so you can then invite each client's ArcGIS Online user into its associated group, ETL their associated data layers into that group and have them separated out so each client can't see the other client's information. In this scenario, you as the developer completely own the layer and are just sharing the data out to them. So you as the developer control the access, the administration of that layer, as well as pay for the service because you're still hosting it in your own environment. And this works for any hosted service, but it also works with any registered service in ArcGIS Online. So that previous pattern we just talked about of registering a service can also be used to actually register it in your own ArcGIS Online organization and then share it out as a group. Another pattern specifically for partners that are sharing services and have a sales authorization for partner user types, you can create a multi-tenant environment using group sharing. So here you are again using ArcGIS Online's inherent multi-tenancy, and everything is being managed by the partner. So here you would take the data from your own infrastructure, ETL it into ArcGIS Online, and from ArcGIS Online, you can share that data into a group. But instead of inviting other ArcGIS users into that group, you would actually provision those partner user type licenses to your clients and then invite them into the group. The diagram here is specifically showing the pattern for ArcGIS Online, but this also works with ArcGIS Enterprise. So if you wanted to directly have those partner user types within your ArcGIS Enterprise environment, that is possible too. In this scenario, you as the partner control access and administration and sharing, as well as pay for the service because it's all within your own environment. And this again works with any hosted or registered service in ArcGIS Online. A couple important tips and tricks for group sharing. Always try to keep them as private as possible and limit the user interactions. You really want to keep the groups as secure as possible so users can only view the group they are a part of. You wouldn't want the public or another organization to be able to see the customer data that you're sharing to them. It's also important to specify who can contribute to the group. So generally, it should be only you as the developer. For items specifically that group members can update, generally, this should be only their own items. Another tip is to give your group searchable names and tags so that the groups are easily discoverable by their users. And if you're completely managing the users in your application, such as with partner user types, you can actually lock down the group even further and prevent your users from leaving so that you are the only one that can remove members. That way you can always keep track and know who the users are in the group. And just to quickly recap and summarize those 4 patterns that we just talked about, for existing ArcGIS users, you can publish the service directly using that access token from a previously authenticated session to directly write your dataset into their organization. And here the user controls access, administration, and pays for the service. That second option was to create credentials for a user and have them reference that service in their own organization, acting as a proxy. And here the user controls the access, but the developer controls the administration and pays for the service. The third option is to use ArcGIS Online's built-in multi-tenancy to share content to existing customers through a group. So here the developer controls access, administration, and pays for the service. And then finally, for non-ArcGIS users and for partners that have a sales authorization in place, you can allow those users into your organization through group sharing. Here again, the developer controls access, administration, and pays for the service. All right, so now let's dive into a quick demo that looks at sharing services via a group versus publishing the service directly in a little more detail. And I'll switch over to my browser where I am running a Jupyter notebook. And here I am signed in to my ArcGIS Online account with my kholleran_cs username. And this is just an ArcGIS Online account that I have access to. And so we'll first walk through how we can share the service via a group. And here I have a hosted feature layer, and this is just an item that I own in ArcGIS Online, and I grabbed its item ID here. This layer should look very similar. It's the same snow emergency parking lots layer that Max used earlier in his demonstration. And what I'm going to do is I'm cloning that item. So Max showed this earlier again when he created the service. And so we're going to take that layer, we're going to put it in this Dev 2021 demo folder. I'm creating an empty layer, and so I'm not going to copy the data because I want my users to then populate that through my application. And I'm also not searching for existing items. And then down here, I'm just renaming that cloned feature layer to shared snow emergency parking lots so that I can tell the difference between my original layer and this now empty service that I'm sharing to my users. And so we'll give it just another second to run. And now here you can see that we have the shared snow emergency parking lots layer, which is that empty item, and it still contains that very fun summary that Max put earlier, but this time I'm the owner. And so now let's show how we can share this service into a group. So here I'm creating a group and I titled it Dev 2021 Demo. I gave it some descriptive tags and a nice description so that my users can easily find it. And I'm setting the access to private so that only users that are invited into this group can view it and that users can only update their own items. And then down here, I'm inviting this kholleran underscore demo username. So this is another Arcgis Online organization that I have access to that is different from my kholleran underscore CS account. And so I'm inviting this outside user into my group. And so let's take a look at what that looks like. So here I'll sign in with that kholleran underscore demo username. And when I'm logged in, you can see up here at the top, I have a notification that I've been invited to join this Dev 2021 demo group. So I'll go ahead and view my invitation and I'll accept it. And so now you can see here, I've been invited into this Dev 2021 demo group. But up here, I'm signed in with my kholleran underscore demo username. And so we'll take a look at this group. And in here, you can see that that shared snow emergency parking lots layer has been shared into the group. And so if I open it, I can view all of its metadata. So this is very similar to what Max showed earlier. I have my fun summary and my fun description. But this time the feature layer is owned by the kholleran underscore CS account. And again, if I go to that data tab, I can see that it is an empty layer. And so now let's go back to that script and we can show how we can publish that same service directly into a user's GIS. So previously we used the username password authentication mechanism, but many times when users are logging into your application, you don't actually have access to their credentials. So in that situation, you may want to use a previously authenticated session. And so I have this application here, and this is just a demo application that Max has created. And I'm going to go ahead and sign in with that kholleran demo account. And we can now see that I have been successfully logged in with the OAuth process. But what's nice is this application actually gives me this access token. So if I go ahead and copy that token, I can actually use that instead of the username here to access this user's organization. And so now if I want to do the same thing and clone that snow emergency parking lots layer, so what I'm going to do is I'm going to clone the item again and put it in this Dev 2021 demo folder. This time I'm going to copy all of the data over and I'm still not going to search for existing items. And so we'll give it a minute to run. but we should see here shortly that this service will now be owned by that kholler and underscore demo account. So just keeping in mind that again, we didn't use the actual username password credentials. We just use that access token that's given when a user is logging into your application. And so down here we can see that we have this snow emergency parking lots layer, again with that fun summary, but this time it is owned by my kholler and underscore demo username. And so let's go back to these slides. All right, so that was a quick demo on how you can use the ArcGIS API for Python to provision services to your users. And now I'll hand things back to Max to close us out.
All right. Thanks again, Kelly. So let's wrap up this tech session with the last part, which is now starting to use these existing data services within your applications. So there are a couple challenges here. One is that your users may already be managing their data in their own GIS system. In other words, your application wants to be a client to that data that already exists. And so one of the challenges there is how do you start to find data specific to your application? Another sort of context here would be that you've created these data services for your users, but that lives among other data, and you still want to be able to find the specific data that's relevant to your application. You may also want to discover some of the data that your users have, because that might add value to your application or the workflows that that application is delivering. And then the third challenge is standardizing the data models. If you're working with a data set that you didn't create, it may not have the data model that you expect. So there are a couple options here. One is to store item information in a user store, and the other is to use the query API, which we'll have a demo of, to help discover, like to query explicitly for the items that you want, or to present the user with different options through the UI so they can select the data set that they want to use. So talking about that first one, storing item information, the way this works is that if your system is the one that's creating the data services, whether by ETL or just that sort of empty create that we showed earlier, then once that completes, you can store a identifier for that newly created service within your backend system. That way, when the user logs in, you're able to essentially fetch the configuration associated with that user from your backend system, bring that into the application, and then start interacting with the defined services from that configuration. And one of the biggest considerations here is that this requires a backend. One, you need a place to store these configuration files, and two, it also requires integrated auth, right? You want to be able to, when the user logs in, ensure that that user is just accessing the configurations that are specific to them from your backend system. So that's option number one. Option number two is that you can search for items that user has access to. So here the user logs into your application, and then you actually use the robust search API that comes with ArcGIS to search for different services, or search for different services that you present to the user to make a selection, and then you consume the services that that user selects. And a couple notes here. One is that the search query responses are specific to the user. So you can query for the data layers that just that user has access to, for example. And you can build out that UI so the user can select the items that they want, and optionally also build a UI to map to your expected schema. So this is the approach that our ArcGIS Hub product takes. ArcGIS Hub has this notion of initiatives that require data sets to back those initiatives. And when a user is setting this up, they are presented with an experience to select the data that they want to feed into this initiative, and then map that data to the data model that the initiative expects. Another search type option is to, if you're the one creating the service for the user, is to use identifiable metadata. So you can create a specific tag, for example, that when your user then logs into your app, you query for. So this can be a little brittle in that if your users update some of that identifiable metadata that you set, that could break the search. But we have used that in a couple scenarios. And one example of that is that solution.js library that I mentioned earlier. When they create new items, they use a tag as a identifier for those items. So what I'd like to do is just show this search API in practice and cover those last two patterns. So let's switch over to the browser again. And here I am logged in to a application that we built to showcase this workflow of users logging in, selecting data that they're interested in, and in this case, using that, enriching that data with weather information. So I'm logged in with my mpayson_startups account, and on the left here, I can see different layers and maps that belong to this account. So I can select on one of the maps, for example, and see it populate with LA spending on sports, which is actually, I think kind of a cool map. And one of the points here about the search API is that it's specific to the user. So if I sign out here and then I sign in with a different account, let's do the mspatial startups account, we now see a different set of data represented over here on the left. Now, the way that this is working is it's using the search API. So let's just quickly take a look at this search API. If we go to the network and start typing in a search, let's say 50, this will fire off a request that performs that search. So we can see that it passes in some query parameters, like the owner of this data is mspatial startups, and it's a type web app or feature service, and the title starts with 50. So we dynamically pass in the search string here into the query, and then we get these response back from that query. There are a lot of parameters in the search API. So here's the REST API documentation for it. You can pass in a query, you can limit by geographic bounding box, you can specify categories or category filters. These are some additional sort of metadata things that you can flag within ArcGIS. And there are also advanced parameters as well. So I believe that's here. And so this is where you can start to search by title and tags and snippets, and then also apply logic like you saw in that REST request to include Boolean operators or range searches through the experience. So this is a quick demo of sort of a generic search within an application. Now, the other pattern I mentioned is that you can specify a specific query parameter that you're looking for. So let's take a look at that in the source code. So here's my search function that is used to generate that query. It uses the REST.js or ArcGIS REST.js search query builder, which is basically a nice builder pattern to define these queries. And you can see how it was constructed. So I want to match the username to the owner, and I want to create a group of the different item types, and then add that search string that gets passed in. Now let's say we want to update this to explicitly look for a tag that we specified earlier. So if you remember, when I first created an item, when I upload that snow parking lot GeoJSON file, I added a tag that was dev 2021. And we can now search for this by saying we want to search for that in tags, hit and, save it. If we go back to the app and refresh the page, we should see that the queries respect that, and it does. So if you remember before, there were more search results, but now we only see those items that have been flagged with the EPC 2021, or sorry, the dev 2021 tag. And if we select one of these just for fun, we'll see that it is loaded into the application, and we get that same symbology that we defined way back towards the beginning of the presentation. And even that pop-up and those fields that we specified earlier are all respected. Okay, so that was a quick demo of this search API in practice and how you can use it to help your users select data that they have access to within your apps, and also explicitly search for things you're expecting to find, like by specifying a tag. And with that, that's the last part of our session. Hopefully, you found some valuable tips and tricks within this content to help you build out your apps. And if you have any questions, definitely feel free to reach out to me or Kelly, and we'll also be posting the code to the Esri Dev Summit org on GitHub. So, with that, we just wanted to say thank you for listening, and we hope you enjoy the rest of the conference and similar sessions. Thank you.